Thank you so much. So there were three assignments for yesterday, and I'll talk about the first assignment, which was looking at quality control using Bombcell and a little bit of Phi for manual inspection. You had a whole little exercise in this GitHub repository, and hopefully things went well, but please comment on Slack or add comments here if you had any issues with anything. So to start out, you hopefully ran Bombcell successfully if you were in MATLAB. And after this, there were just a few questions to kind of assess if you understood how to access the data outputted by Bombcell and how it was kind of working. So the first one is, what is the number of spikes in the unit with the kilosort or phi ID of 2? And sorry, let me put that here. So to do that, you could just, in the example section of the main script, change this to 2. Oops. And then if you run this section, you should be able to see the output, which is like 34,000 spikes. Then the second question, can a unit be classified as multi-unit if it has more peaks than parallambda n peaks? So this is to try and clear some issues that sometimes people have understanding the algorithm. Bombcell does things sequentially. So it will first assess, I can bring up the flowchart. It will first assess whether a unit has any noise, and for that it uses noise metrics, which include the number of peaks. And so if a unit has more than a certain number of peaks, it will be classified as noise, and it can't be classified as any of these other categories. So hopefully that makes things very clear. Okay, and once you've run Bombcell, I think one of the strengths of this software is that you have a lot of output plots to look at, and you can like quickly assess how well it's performing on your data and the quality of your data. So, well, the first one that is outputted, and we've added a little image here, is this one, where for each classification, noise, good, which are single units, multi-unit, and non-somatic, all the waveforms, so these are the mean, well, sort of the template that's outputted by kilosort that's been unwhitened. That's very important. And on the peak channel for each unit. So each of these lines is one template for one unit that are overlaid. And what you can hopefully see in this example, I'm trying to zoom in, that's a bad idea, is there's a lot of stuff that's being removed by noise unit. That does seem reasonable. You know, none of these really look a lot like a normal, traditional, nice neuronal somatic unit. You can also see in the non-somatic, they have this very characteristic shape that does correspond to non-somatic units. And here in this example, we had changed a few parameters to some kind of absurd values. We had changed the number of peaks and the spatial decay parameter thresholds, which hopefully you noticed. And you can now maybe see that there are all these lines, a few units here that appear, you know, really quite noisy. There seems like maybe there's something a little bit weird going on, and that might be an indication that you want to take a more careful look at what's going on and if Bombcell is actually doing a good job in these few units. And the rest of the plots will help with this too. So, sorry, I need to go back actually. So this was the question, you know, do the waveforms look well classified? Well, I would say that in the good units, there's potentially something a little bit weird going on a small subset of units. Okay, and now you can look at their other output plots, which are the upset plots that Bombcell outputs, and we'll just look at one, but it outputs one for looking at units that are classified as noise, one for non-somatic, and one for good units, well, multi-units. And I just wanted to go over this because they can be a little strange to read if you haven't seen these plots before. So on these plots, you have, for each of the quality metrics, the number of units that are removed by that metric here, and this is the set size part. And then you can see how many of those units were also, units removed by one metric were also removed by other metrics. So for instance, the question was, how many units are removed by the number of troughs? That's about like 45. And then if you look at this dot here, which has no other connecting lines, this corresponds to the units removed only by this one metric, and that's 12. And actually most of the other units are removed by several of these quality metrics. This is usually an indication that the software is working pretty well, that units are removed by many different metrics usually. And here you also want to see if there's one metric that's, removing an abnormally large amount of units. That may be an indication you need to fine tune some things. And units and quality metrics that are removing no units. So here the number of peaks is removing nothing, and that's a little suspicious. So something you might want to pay attention to. And then finally, the last plot is these distribution plots that are outputted by Bombcell. And this is for each unit, we're showing just a distribution here, for instance, the number of peaks, and red indicates, so here's a threshold, and above that, you're classifying your units as noise. And you might see that here, the number of peaks seems a little odd. Probably you would want to set your threshold a little bit lower. And it can be useful looking at these plots also to see if there's some sort of bimodal distribution, for instance here, and those can be a natural area to place different quality metric thresholds. Okay, and I just see that I have 1 minute left, so I might post the answers to the rest of this exercise in the Slack, because I think we won't have time to look through it all. But now looking at the GUI, which we'll just look at the screenshots here. So the GUI is in two parts. There are two panels that are connected to each other, and you can flip through units. And here you can see, the waveforms and the spatial decay of a particular unit, the autocurlogram, all these useful plots. And on the left side, you can see where this unit is in the distribution, and that's indicated by this line here. And that can be very helpful for setting thresholds. So here, for instance, this unit should not pass the spatial decay threshold because you can see there's really no spatial decay. And we can look at where it is in spatial decay and think, oh, okay, we probably need to adjust that threshold and have it be a little bit higher than what it currently is. For this other unit, it definitely should not pass the number of peaks. And so again, we can look at where it is and we probably want to adjust this quality metric. And I think the time's up here, so I'll just post details for this last section looking at phi in the Slack channel.